Right. Initially was a programmer and then a technical director. And he has coded in many languages, including C, C++, Perl, Java, Ruby, Visual, Basic, PHP, and many, 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 many more. He is the backend API developer of aeternity and is an SDK team lead. So, Mr. John Newby, please welcome, guys. Yeah, it should be. Check.
Check.
Yep, there we go.
Okay. So the title of this is Development History and Journey of Eternity's First Backend API. I'm not quite sure how accurately this talk fulfills that promise, but at the end of it, you should at least have a good idea of what the middleware is. So first of all, who am I? I am a programmer, the originator of the middleware, relatively new in the blockchain space, but online since '91 when I fell in love with the internet and never fell out of love. My most recent experience has mostly been doing really high volume serving on minimal hardware, and I think that was what sort of informed a lot of the choices that we made with the middleware, which I think will become clear. So what is the middleware? It's a caching and reporting layer for the Eternity blockchain. It was recently, today, renamed to Eternal, but because I didn't want to update the presentation, we will continue to refer to it as the middleware. But the really important question is, why is the middleware? It all began with the original blockchain explorer. So this was the page that people saw when they looked at the initial iteration of the blockchain explorer. And there is not an enormous amount of information on this page, but it turned out that in order to get that information, one had to ask an awful lot of questions. So we had to ask once for the top block, 4 times for a generation, and then 248 times for all of the transactions in a microblock. And the elapsed time for all of them was 37 seconds. So interactive performance was not really one of our strong suits at that stage. So we made a little thin layer which stored the data in a SQL database, and we then got our queries down to 0.14 seconds, which was significantly better. And in the course of doing this, we preloaded the transactions for the next page where the user could get detail. The middleware is written in Rust, which is a very beautiful programming language. Its major plus from my perspective is that by the time you get your program to compile, it's basically guaranteed to run. Compiling it can be a bit of an adventure. It's backed by a PostgreSQL database, and it sits in front of the node and is compatible with the Node API. So if you talk to the middleware and you don't use any middleware features, you can just treat it as a node. It gives you information faster than the node in some respects, but it should always be consistent with the node. I say many threads. We have between 4 and hundreds, depending on how many HTTP processes we use. And we coordinate between the threads exclusively using the database or using a message queue. When I say many modes of operation for flexible use, what I mean is that you don't have to use any part of the middleware that you don't want to use. So you can just use it to load into your database, or you can use it to do HTTP serving, or you can run many HTTP serving processes backed by one loader. So you can use it as well as a load balancing proxy for the node, which gives you a consistent view of the node rather than round-robining among several. Like everything good, the middleware has a philosophy, and our philosophy is to make the blockchain data easily accessible and queryable, that you do not have to trust us, but you can trust us, and that you can easily verify that we are truthful. And as I just said, we provide a front end for the node. So the way we attempt to accomplish this, so we host our own middlewares, one for the testnet and one for the mainnet. They are currently extremely reliable, but they could be more reliable. But if you throw enough hardware at a problem, everything goes away. We share daily database dumps, because running your own middleware and starting from a node, especially the public ones, it will take about 2 days to index everything. So rather, you can download a gigabyte dump, and in 10 minutes, you have a database which you can use. Trust but verify. So when you have your database, which you have restored from us, you can then query, you can then in your own time run through it and get it to check against a node of your choice. So this is my screenshot of it happening. The top height is very rarely consistent because there are always microblocks being added. So unless there's no transactions going through, the top block should always be different. But after this, it should all just pass. You can verify a database while you are using it, and verification still takes a very long time. This is our schema. I don't think it's super interesting, but one thing which is another philosophical point is you can see there's not very much in it. We tried to be quite agnostic about the blockchain and only know as much about the blockchain as we have to. So we have to calculate channel identifiers, we have to index contract calls and unpack their arguments, but for things like most stuff to do with names, we can just query straight from the transactions table. The TX column in the transactions is a JSON-B, which can be directly queried inside the SQL. So we can get away with a database which is quite dumb and keep most of the clever stuff in the application logic. What do we index? We index key blocks, microblocks, and transactions, and we build like 20 indexes on top of them for fast querying. We register names, we index names registered, and very soon we will be showing metrics about auctions ongoing, what the prices are. We index the contracts, and we unpack all of the argument of the calls to them. We index state channels. We always index identifiers from everything. And as I said, we can query the JSON. So we also, these are the methods that we return our database data for. And the reason for doing that is just speed. If we don't know something, because there's some inconsistency, we then just go back and ask the node. So we always rely on the node as the ultimate source of truth. And just to give a quick view of our API, so you can see what compilers we support. You can look at all the contracts, all of their calls, all of their transactions. You can verify a contract, so you can give some source code and confirm for yourself that the bytecode on the chain is in fact the compiled version of that contract. We'd have lots of stuff with names, lots of stuff with oracles. We can tell you how much Coinbase was generated at any particular height. We can tell you the aggregate size of all transactions. We can tell you stuff about an account. And we also do events. So we have a WebSocket connection which you can connect to, and you can subscribe to events which you are interested in. You can subscribe to key blocks, microblocks, or transactions, or you can subscribe to any object on the chain. The use cases for that one are, for example, if you're interested in a particular account, you can subscribe to that. If you are running an Oracle, you can wait for events to come in that refer to your Oracle, and then you can respond to them. So we try to make it easy to be asynchronous. As you can see, if you subscribe to every transaction, you get quite a lot of output. Who's currently using the middleware? The governance people are using the event loop and only the event loop. The base app is using transaction history. The Explorer and the middleware front end obviously use the middleware. AirGap are using it for list of transactions, and we do a lot of ad hoc reporting when we want to find out what's going on, what kinds of transactions there are, what's been going on. And of course, because we have a Postgres database, we can just ask it any question we want. So this was looking for anybody who had claimed a name, and the answer to that was nobody had. Okay, so that was a very fast wrap-up. The future of the middleware will involve a contract store, involve GraphQL. We have a library we wrote which talks Gossip to the nodes, so we can pull transactions directly from Gossip rather than using the HTTP API. We are going to let the public connect to our read-only replica and hammer it with whatever query they can think about. It would be really lovely to make some reporting and network traversal bits so we could maybe connect to several nodes, see how transactions are flowing between them, get some idea of the network topology, and ultimately it would be great to support more blockchains. And that's the end. Hans. Any questions? Yes, didn't show.
Well, some female substitution is also not bad, you know. So yeah, Dincho.
So, I have actually 2 questions. I just talked to Mark from China outside, and they have latency issues in China.
Mm-hmm.
Do you plan some multi-region setup of the service? And the second question is, do you plan some HTTP caching for the middleware? I mean, the only middleware API endpoints, because I plan to proxy to the middleware as well from the API gateway.
So, sorry, you want to cache
HTTP cache?
on the front of the middleware?
No, just the middleware. I mean, the HTTP response of the middleware to include the HTTP cache headers.
Oh yeah, cool. We should do it.
What about the multi-region?
Do you mean we should host in different regions?
Yeah.
Yeah, sure. I mean, if people give me the money, I will put them everywhere.
Okay, thank you.
Any more questions? Yeah. Cool.
I really like the trust but verify part, and I would like your standing when it comes to how much trustlessness is good and how much should be just trusted, but a few, let's say, policemen and women that go around do verification, kind of check that the stuff that we trust is trustful.
Yeah, I think it's context dependent as well. If I do a transfer of 1 AE, then I can really afford to just find out if the transaction turns up. If I'm transferring millions, then obviously I'm going to take a very different view. But I think the thing that's really critical is to permit people to have a good idea of how much risk they're taking so they can make their own informed choice.
And will such stuff also be kind of, like, are you thinking about how to prevent that people fork and make a malicious middleware kind of thing? Like, have you ever thought about it, or is it only like, you can trust us, but then if you trust someone else?
Yeah, I mean, I guess we're associated with aeternity, so some amount of trust has to go with that. But the ultimate thing is just download your own, spend a day checking it out. It's a very lightweight program to run, so you know you can just run one in the background. You can turn it on once a day so it catches up with the latest chain stuff and turn it off again.
Cool. Thank you.
One more?
Yeah.
2.
2?
And
Elo was money.
you have written maybe connect to several nodes. Do you mean of making network out of them or just like replication of themselves? And second one, more blockchains part is very interesting part. Can you talk a little bit more about it?
Yes, so we connect to several nodes is to get some idea of the speed of stuff going through the network. Maybe this problem of latency, we connect to one in China and then we have an idea of what's going on over there. Maybe it gives us a heads up about the health of the network and what's going on. So this is kind of about knowing the health of the network rather than to develop our own idea of the truth. I think there's always got to be a node that we're relying upon, otherwise we start to grow into the node role, and I don't want the responsibility. More blockchains. I mean, some of the stuff is very specific to aeternity, of course, but there is a generic blockchain structure, and it would not be impossible to build backends for multiple blockchains. Maybe provide something so at the level where they're relatively similar, you can interact with them.
Right. And do you want to follow up on that? No? Okay, well, thank you. A round of applause. Thank you.